I think we can start, right? Where is the... Okay. So people will come from lunch, but it's 1, and so we start our session. The session today is about Power BI, is about performance in Power BI. The title is My Power BI Report is Slow, What Should I Do? And we will try to answer to this question. At least we will try to see where we can start. And the latest version of, the latest 2 versions of Power BI introduced new features that we will see, but we will also see other tools that can be useful in order to help us understanding where is a bottleneck, where is a performance issue, and what we should do to fix it. My name is Marco Russo. I'm from SQL BI. Bhavik Merchant will speak shortly, presenting the features of Power BI. He's the PM that, no, he works in the SQL CAT team, right? No, you're a PM. Okay, he will present himself, don't worry. And so he will tell you exactly more details about this. So what are we going to, oh, why its model is there. What are we going to do now is, this is I don't know why the format is broken now, but sorry. The agenda is we will investigate in a few tools we can use beside only Power BI, and we will see a few techniques that can be used. This is the reason. There was another. And you can download the slides and most important, the demo file that I will use. So if you want to try the same example that I will show you in a moment, I have a dashboard that has some performance issue. So this way you can use the same file and make the same analysis that I will do. Of course, I suggest you to try the same techniques with your models, but if you say, Marco, my model is faster, how can I find a slow one? We will have an example here that you can use, okay? So I give you time to get the picture with the QR code, or otherwise you just write the short URL that will help you finding the file. Okay, so let's go to the first section of this part, which is the Power BI Performance Analyzer. And before introducing Power BI Performance Analyzer, I want to introduce the sample file that I prepared for this demo. This is a very simple model. You see now an empty page, and I will explain you in a moment why this. But this is the model I have. It's a very simple model where we have sales, we have product, customer data, and segments. Let me just use the zoom it so we can see in more detail some small font that we might have in our report. And this is a very ideal situation. So we don't have a problem in the data model in this case. In the real world, you probably have much more tables, relationships, and the number of problems could be much bigger. But in order to understand the tools, we want to have a simple problem to solve. Then, of course, when we have a more complex problem, we will use the same tools, just we don't want to lose too much time in the problem by itself. We want to understand what are the tools and the techniques that we have to use to investigate. So what I'm going to do now, as you see, my page here is an empty page. I don't have a report, because I created an empty page here, and I saved the file with an empty page, because you might have a problem when you open the file the first time. So you open the file, or you open the report the first time in Power BI, and you wait for a few seconds, or maybe minutes. But let's say just a few seconds is already a problem. So how can we start our diagnostic about what is going on if as soon as we open the file, we see the report? So one technique is I create an empty page in my Power BI file, in my Power BI report. I save the PBX file using this file as the current one. This way, when I open the PBX file, I have an empty page. At this stage, because my report is empty, nothing happens, no queries are sent to the engine, and so I'm ready to, later on, to start my diagnostic tools. At the moment, I don't do anything of this. I just want to show you what will happen when I open the report. So if I click on this sales page, you will see a number of reports appearing, and one of them is slower. Slower doesn't mean minutes, it means a few seconds. So because we will repeat this operation several times, I didn't want to use something that requires a minute, because otherwise the session would be waiting 1 minute every test. We just have to imagine, okay, if this was instead of 3 or 4 seconds, 20 seconds or 30 seconds, we would use the same technique. So let me see what happens if I click on sales. You see I have several visualizations. And one of these visualizations, the one on the bottom left, appeared later, appeared after a few seconds. What happens in this case? Well, first of all, having many visualizations in a report could be not necessarily a good idea for 2 reasons. One is that every visualization might require resources from your browser, if you are connecting to PowerBI.com, or from your Power BI desktop. Second, every single visualization generates at least one query, one DAX query to the engine. In this case, the local engine. It could be a remote engine. Just to give you an idea, I always like to also show this. If you open the Task Manager here, the Task Manager is a Windows tool. Actually, every Windows operating system has this tool that allows you to see what is running on your machine. So this is the window of the Task Manager in Windows 10. And if you look at Power BI Desktop, Power BI Desktop is a single window that you see, but if you open this, you will see several processes running. This gives you the idea that when you run Power BI Desktop, you are running an entire client-server stack of services that provides you the experience of having a data model and a visualization. And one of these services is Microsoft SQL Server Analysis Services. So when you get your free version of Power BI Desktop, you get a free version of Microsoft SQL Server Analysis Services, which is a product that costs a lot of money, but it's the same engine that runs Power BI. So the difference is when you connect your browser to PowerBI.com, this analysis services engine is running in the cloud, managed by Microsoft. But when you are using Power BI Desktop, this instance, this process, this local instance of analysis services is running on your machine. Why this is important? Because if the problem is in DAX, the problem is in that process. And you might see that this is the process that is consuming memory, this is the process that is consuming CPU. If the other processes, these browser sub-process, when you open Power BI Desktop, you don't have a browser. Well, not really. You have a few instances of a browser running within your application. So the rendering of the report is HTML5 with JavaScript, and it is running there in these processes. So if you see that these processes consume a lot of memory or a lot of CPU, guess what? It's a problem of the visualization. If you use a visualization, maybe a custom visual or a map that has 30,000 points, I guess that you will consume a lot of memory, a lot of CPU. So this is the first thing that you can observe. Now, why I'm showing you this? If you look at my Power BI Desktop, this report is consuming more than 1 gigabyte, not a small amount. And who is responsible for that? If I drill down, I can see that this consumption of memory is distributed between the desktop, the shell of everything, the analysis services that has my data and is running my query and my cache and everything else, and my browser sub-processes that are different instances of this rendering engine that provides me the visualization. I would say that I don't have a problem for the custom visuals or for the visualizations by itself, but if instead of having this ratio, I had, for example, 500, 600 megabytes for these browser sub-process events, I will suspect that I already have something going on here. However, even though if you don't go at this detail, I will show you in a minute, another tool that can provide me some information. Because if you are consuming memory, you probably are also consuming time. And if you are consuming time, we can detect this using a tool that I will show you in a few seconds. Now, I'm not interested into the report by itself. I'm only interested into the experience that the user has, that when I open this, I have to wait. And if I click on a slicer here, look at this. I have a slicer here. When I click on, for example, Asia, you will see that there is something spinning, and one of these elements appeared after 2 or 3 seconds, okay? Your experience may be different. Marco, we wait 20 seconds. Okay, but the tool I will use is the same. What I can do at this point, I can start an analysis using the Power BI Performance Analyzer. You go in View in the ribbon, and you click on Performance Analyzer. At this point, you have a new pane, which is this one. And this is a pane that allows you to capture a number of events from the engine, from the rendering engine, and from the calculation engine that will be displayed here. Now, just to get more space and don't lose the visualization, I reduced the feeds and visualization filters panes, and I will start the recording. At this point, I can click refresh, and when I click refresh, what happens is that I re-execute rendering and a refresh and a request of all the visualizations that I have in my page, and I will see the result. However, when you do that, you might not get an exact timing because guess what? I already executed this report. If you think about this, sometimes the problem is that the report is slow the first time. Then after a while, it runs faster, but we want to detect the reason why it is slow at the beginning. So for this reason, I would suggest, especially if the problem happens when you open the report the first time, what I could do at this point, I close everything, and I restart my analysis from scratch, this time activating the Performance Analyzer before I I start my Power BI Performance Analyzer before I click on the page sales. So I open the file again, and in a few seconds, I will repeat this test. The information that I will see in the Performance Analyzer pane will help me understanding where the time is spent. So I start the recording now. At this point, I don't have to click on Refresh Visual. I just click on Sales, and I see what happens. As you see in this pane, every single visual is tracked here with a duration. The duration is how much time has been spent in order to retrieve, in order to complete the rendering of the visualization. And as you see, wow, there are one visualization spends almost 5 seconds and the other 2 seconds. And the first thing that you can notice, these timings are not cumulative. I didn't wait for 1 minute. I waited for 5, 6 seconds. So actually, many of these tasks are executed in parallel. But of course, we are interested into the more expensive one. And look, we have this matrix that seems to be the slowest one. If you click here, you see that if you click on a visualization, I click it here, this has been highlighted. If I click on this one, this other is highlighted. So you can check what is the visualization that is responsible for a high consumption. But as you see, when I open one, when I drill down in one visualization, I also see other information, which are 3 numbers: DAX query, visual display, other. And it seems that other is the biggest problem. Now, don't be confused. The way you have to analyze these numbers is the following. What happens when I open a page? Many visualizations ask for data. The engine receives 50 requests in this case. But the engine cannot satisfy 50 requests at the same time. So it will satisfy 1, 2, 3, 4, 5 requests in parallel. Then the engine will wait that some request is completed, and then will execute another one. If you think about this, it's like you have a queue. The engine can satisfy a few queries in parallel, but the other visualizations might have to wait. Might have to wait because there are not enough resources available, or because you might have a visualization that depends on another visualization because of the transfer of the filter. You have a slicer, and the slicer filters something else. So there is an order in which they have to be executed. Now, this waiting time, the waiting time between different visualizations is other. Okay, other could have something else, but 90% of the times when you see other, is just synchronization timing. So the best thing that you could do, ignore it. You want to focus on the other two numbers, which are DAX query. How the engine can render this number. First, it generates a DAX query. Second, it sends this query to the engine, our SQL Server Analysis Services engine. Then it waits. Sorry, not other. It waits for the execution of the query and the result transferred to the visualization. Now, the time that is spent between preparing the DAX query, sending the DAX query, and waiting for the first row of the result is what is called DAX query. If I see DAX query 7, these timings are in milliseconds, well, it is not an issue. Any number below 20 milliseconds could be just noise. You run this query again and again, you see 7, 5, 10, 12, doesn't matter. Ignore numbers that are too small. Smaller than 16, ignore it. Then we have a visual display, 20. 20 milliseconds means, okay, good enough. But if you see 200, 300 milliseconds, it starts to be consistent. It is time spent in the rendering engine, HTML5, JavaScript, client side. Is not a problem of your model. It's a problem of the visualization. You have too many points, use some expensive resource, graphical resource, or you're using a custom visualization that is particularly slow. I don't know, okay? Now, at this point you say, Marco, but when I have so many visuals, what should I do? Well, you have to sort this visualization here, for example, in a descending way. So if I do this, the more expensive visualization is the first one. But because I said, wait a minute, I see that here, this is 2 seconds of DAX query and 2 seconds of other, but am I sure that this is the more expensive visualization in this page? What you should do, once you recognize, okay, visual display is not the biggest problem, here I can decide to sort by, for example, the time of the DAX query. You can sort by action order, by the sequence of visualization that you had, by the DAX query timing, visual display timing, total time. This sort by has been introduced yesterday. Until 2 days ago, you weren't able to change the sort order using DAX query, and you were always using a number that was confusing. Now we can sort, for example, by DAX query. Now I'm sure that this matrix is the component that is generating the more expensive query. And so this is my responsibility as a data modeler, as a DAX developer. I can do something now. I can try to optimize this code in order to improve the performance of my report. Just to take a look, if I go to the second one, you see that the second one is spending 2 seconds, but actually I cannot do anything. Because when you see other, it has to wait synchronization because I had so many visuals and it was not possible to render 20 visuals at the same time. That's the only problem. If I had some visualization that depended on the matrix that was rendering in 4 seconds, the other time would have been 5, 6 seconds. But usually you don't have the ability to do much over other. You can act on visual display, you can change the visualization, reduce the number of points or doing something like that. You can do something if you have a slow DAX query. Okay, so these are the actions that we can, the parts that we can, where we can do something. At this point, you see here a copy query, and copy query is an interesting feature because it copies the DAX query that has been generated for this particular visualization, and I can copy this in the clipboard. And just to show you, I can have this, where is my notepad here? Oh, another, wait a minute, how is it possible? Okay, let me try another, okay. I don't know why it was displaying somewhere else, but this is my query. Okay, this is the DAX query that has been generated for that particular visualization. What can I do with this query? We will see this in a moment. So I have this feature, and I would like to invite on stage Bhavik. So let me check if I have the slide that you provided me with the roadmap. Because as you see, this is a new feature that now we will see how we can use in a meaningful way. But the idea is that this is a new feature of Power BI that is not complete. I would say that there are new features coming. So please, can you tell us what is going on in the next few months?
So thanks, Marco, and I'm going to kind of touch on a couple of other areas. So Bhavik Merchant, I'm a senior program manager on the Power BI service team, and my job is performance. So you can come complain to me in a bit after the presentation. So one of the things we're going to do is we're iterating on this performance analyzer all the time. So as Marco said just yesterday, we added the sorting features. One thing he didn't mention is you can actually get the direct queries now there too. So if you have a DQ model, you actually see the direct queries that will be sent. And as we collect more feedback, we're going to add more features there, potentially coloring, to help you identify the slowest visuals and things like that. We'll see. But in other areas, one of the problems you're going to have is it's all fine trying to optimize performance, but setting a baseline and understanding what your performance looks like is a problem right now. People are using external tools to hit the Power BI service and figure out how fast things are. So what we do right now is, most of you will be aware of the usage metrics we have at the workspace level. We're extending those in the next quarter to actually include performance metrics. So you will have trends once we collect enough data, you will have percentiles, and you'll be able to break down, in a second iteration of that, you'll be able to break down individual executions. Where was the user, what browser were they using, what version was it, where were they geographically, and so on. So you'll really be able to understand, is it just a certain pocket of users, is it certain times of the day, or is it certain geographies or places like that that are experiencing performance issues. Next up, if you're using premium, we've done a lot of work on premium capacity metrics, but we feel there's a lot more work to do. The main problem we have is there's too many metrics and they're not all laid out in a way that you can figure out a problem straight away. You've got to bounce between different tabs of that report and figure out, my CPU is high here and did I have refreshes going on at the same time? So my colleague David Magar is working on, and Swati Gupta, two of them are working on actually enhancing that to provide you a better snapshot of what's going on. And over time, we're actually going to add some suggestions in there. So rather than having you figure out what was going on, we're going to tell you what was going on in a certain time period, like, hey, you had way too many users here. And then over time, we're going to actually make that actionable. So you will actually be able to press buttons and do things in the UI. And we're no longer going to have an app. So work has already started to actually build all that admin experience into the admin portal. So you won't have to install that capacity metric apps and so on. There's a few controls coming to prevent overutilization on premium capacities. So CPU interleaving to allow you to share a CPU a bit more fairly so that long-running complex queries don't starve other queries. You'll be able to set row limits that you can bring back, because if you're a premium capacity administrator, you might want to increase the limits. And we're also going to add ability to control the amount of memory that your data sets are going to be able to consume, just to prevent capacities from being starved by one or two very busy workloads. And finally, there is obviously documentation work planned. So work is already underway to create specific performance articles in every single area. So visual layout, some of the stuff Marco's going to talk about, slicer optimization, model optimization, et cetera, et cetera. So that's all I had. I just wanted to talk to you a bit about roadmap. Thank you for the time, and I'll give it back to Marco.
Thank you very much. So this is just a quick recap in the slide about what we did. We basically opened Power BI, started the performance analyzer, started the recording, intersected the events and displayed the events, and at that point we can copy a query. But what can we do with this query? I've shown you the query in an editor, but in reality we would like to analyze in more detail why that query is particularly slow. And at this point I introduce you DAX Studio, which is an open source, a free open source tool that is available to test, run, analyze your DAX code. DAX Studio has been written mainly by Darren Gospel, who is a Microsoft MVP, who lives in Melbourne, Australia. And I wrote a very, very tiny part of DAX Studio, so please don't, people say, oh, DAX Studio is wonderful. Yes, but it's Darren product. But it's an open source product, and actually in the last few weeks, we finally have seen some other people contributing with some code, with some pull on GitHub. So if you have C# skills, you like to introduce some new feature, you are free to contribute. Now, what is DAX Studio? So you can download DAX Studio from this URL, and what you get is this tool. So I open DAX Studio, and DAX Studio is like a SQL Server Management Studio for DAX. So at the beginning, it asks you to connect, and he would like to connect to analysis services. The tabular server that you see here is analysis services. But guess what? We have Power BI. Power BI Desktop, however, is running analysis services behind the scene, so we can just say, look, you know what? I want to connect it to Power BI, and here, when you click on this combo box, you see that we have a list of the open Power BI desktop files in this moment. So the idea is that I can connect to any open Power BI file that you have. Only Power BI files that have the data loaded in memory or in direct query. If you are connecting live to analysis services or to Power BI .com, for example, then you are not able to connect locally to Power BI. You have to connect it to the server. So you always have to connect it to analysis services. Now, in this case, I just connected to this instance of Power BI Desktop. And you see here that in the pane on the left, you see the list of tables and the list of columns that you have in the model. You can also search for a particular measure, for example. I can do this, and I can see, for example, sales amount. I can do several stuff. And the idea is that I can write here some DAX code. For example, the easiest query that you can write in DAX is evaluate followed by the name of a table, for example, product. So if I write this evaluate product, is like saying in SQL, select star from table product. And if I run this query, I can see here the result of this query. So far, doesn't look so interesting, but remember, I use the copy query, and I retrieve in copy query this query in the clipboard. So if I use copy query and I paste this code here, what I get is the ability to run this query again, and I can see what is the result that the SQL Server Analysis Services is providing to Power BI in order to populate the visualization. Every visualization sends a query, and every visualization receives a table with data, and this table with data is used to populate the visualization itself. Now, let me go back to our report. If you remember, my matrix that is low is this visualization. Now we can enter into the analysis of what is happening. For some reason, this visualization is low. Now, I could skip all these steps and say, OK, there should be a measure that is low. But I want to show you all these steps, because in case you had many measures, many visualizations that are similar, you have to identify the individual steps that are needed in order to identify the single bottleneck that is affecting the performance. In this case, you see that my visualization is rendering a table that has two columns, products and customers. However, the query that is run by, the query that I run in DAX Studio is returning three columns: product name, is grand total row, total, and customers. So what is this column? If you look at this column is always false, and it is true just for one row. And this row doesn't have a product name. Guess what? This is the total. As you see, every number that you see in a visualization in Power BI is computed by the analysis services engine. So one of the challenges in DAX doesn't know what you are doing in the visualization. And the query asks to analysis services all the numbers, also those numbers that could be obtained by just summing all the numbers that you have in a column. So sometimes you have to understand that the result provided to the visual is not exactly provided in the same way you see the data in the visualization. For example, in case you create a matrix that has the colors in the rows and the years in the columns, and a measure in every cell, you will see one row for every cell. And so the result of DAX query is never a matrix. It's always a table where every number is one row. Every measure is in one row. But usually, because we know now that this is the query generated by this visualization, this matrix, we can identify exactly what is the query corresponding to each visualization. Before Performance Analyzer, it was much more challenging because we were able to intercept the queries with DAX Studio itself, but we were not able to clearly identify which query belonged to each visualization. So this helps me a lot. Now that I know this, what can I do? Well, DAX Studio has some additional tool that can help me investigating on a query. And these tools are these 3 buttons that I will show in a moment. But if you download DAX Studio today, or you downloaded DAX Studio in the last few days, the latest version of DAX Studio, the 2.9.1, has this additional feature, load perf data, which enables me to load something that the performance analyzer pane could generate for me. Sometimes the problem is not just one DAX query. It could be, could appear in many, many DAX queries. So I want to show you another feature that we can use, which is the following. You see that the performance analyzer here has this button, export. Okay? Think about this. If I have 50 visuals, 30 visuals, I might have to copy and paste one query at a time, 30 queries, if I want to analyze all of them. So I can export this file, and I can create a file here. Let me go ctemp demo performance data. So I save it a JSON file in my temporary folder. Now I can go in DAX Studio, and I can click on this button, and I can simply load the file that I just saved. So if I go here and I open this file, you see that DAX Studio opens this PBI performance, which displays the very same information that we had in Power BI in a pane where I see all the individual metrics. So by the rendering time in the visualization, the query time for each query, and the number of rows returned by each query, which is, for example, a number that was not available in the other visualization. So the JSON file that the performance analyzer saves has a lot of more details that we cannot see in the pane of Power BI. And sometimes this could be useful. But the reason why I like to use this is because I can easily sort by the query time in DAX like I did now, so this way. And once I see this is the slowest query that I have, I can double-click this line, and the query is copied here, including a comment that you didn't see when I use copy query, that includes a few other information that gives me more detail about what happened. So basically, we can use many additional information provided by the performance analyzer that otherwise we will not see. From here in after, it is the same. So if I copy the query manually or I use this technique, from here in after, the experience is the same. And the experience is the following. Let's say that I want to execute this query again, and I see the result, and I see that this query is executed in 2 seconds. You see here, in this area, the execution time, but also the output here tells me that this query has been executed in almost 3 seconds. Well, first of all, sometimes the query is slow the first time and not at the following execution. So it's a good idea to clear the cache of analysis services and then run the query again. Because this is an operation I do often, I have the ability to switch this button to this mode that every time I click the button, it clears the cache and then run the query again. If I do this now, I will check whether my execution time increased or not. And let me see the output. Yes, it increased almost 1 second. So actually, having the empty cache puts me in the in the worst possible condition for the performance, which is exactly what I want to do. Because when I do an analysis of a query, I want to exactly be in the worst possible condition. Query plan and server timings are 2 buttons that activate a more detailed analysis of a single individual query. It would be very expensive to activate these 2 analytical tools for all the queries. So the idea is that once I identify a query that is slow, I copy this query in DAX Studio, I activate this additional diagnostic, and then I run the query again, possibly by clearing the cache before. If I do this now, I obtain these two results. You see that when I click at these two buttons here, I obtained here other two panes, query plan and server timings. Let's start with the query plan. The query plan is a pane that has two areas. One contains the logical query plan, one contains the physical query plan. As you can see, it is not as nice as a graphical visualization like you have in SQL Server Management Studio for a SQL Server query plan. And to be honest, it will not be so useful because these query plans could be very, 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 very long. And one thing that you can notice here is actually that this physical query plan at a certain point started a number of requests. When you see cache, this is a request made to an internal engine. I will describe this in a moment, don't worry. And the second part is the server timings. The server timings is a pane that intercepts all the low-level details activity that the engine does. And for example, here I see that the total execution time of this query, that was around 3 seconds, has been consumed by two parts of the engine, the formula engine and the storage engine, according to this division of the roles. We had a number of storage engine queries internally, 1,000, very big number, and so these numbers help me understanding what is going on. However, before I go deeper in this area and I introduce you to the numbers that we are seeing, I want to introduce some other tool that we are using that can be helpful to understand what we're doing and the numbers that we analyze. So far, we have seen DAX Studio, and I didn't mention, DAX Studio has an interesting feature, which is when you have a DAX code that could be not formatted nicely, you can click on Format Query, and this, when the code is compatible, this is not compatible, this comment is still not compatible. When you click on Format Query, this reshapes the query format so that it makes the code more readable. So there is a tight integration between DAX Studio and the DAX formatter, so you don't have to open the website to do that. The operation I performed by saving by exporting the performance analysis data and importing this information in DAX Studio are described in this slide. And the link that you see in this slide points to an article that describes the operation that I've shown you step by step with some screenshots. Okay? But the numbers that I see in DAX Studio, especially when I start to talk about the formula engine, storage engine, well, every number you will see is relative. It depends. Is this number big or not? A storage engine query that runs into 100 milliseconds is a fast or slow storage engine query? It depends on your data. So you have to know your data model first, and the right way to understand what you have in your data model is to measure it. Just assuming that you know how many rows you have, how many unique columns you have, what is the size of this column in memory, you don't know that. In order to know that, there are data management views that can provide this information, but this would be very, very boring, running a lot of queries manually. So the tool that we can use today is a tool called Vertipack Analyzer. Vertipack Analyzer is another tool that you can download from the web. You can search for Vertipack Analyzer. It's very easy to find. Also, you go to sqlbi.com tools and you will find it. And it's an Excel file with a Power Pivot model. But of course, now this model is not refreshed with the information of my Power BI file. This is the sample data that we provide in this Excel file. So what you have to do is, I want to refresh this model that collects all the statistics about the data that I have in my model using my Power BI file. What can I do? Well, this is a Power Pivot data model that collects data from data management views of analysis services, and Power BI runs analysis services. So if I refresh this, I just have to change the connection string of this Power Pivot data model, providing the same connection string used by DAX Studio to connect to Power BI. So this is the technique. You have to go here in existing connection. And by the way, this is described in an article when you download the DAX Studio step by step. But I just want to show you that the idea is the following. I'm editing the connection string of this Power Pivot model. And as you see here, there is a string. I have to replace this string with what? If you open DAX Studio, here you see the server name of the analysis services you are connected to. And when you connect it to Power BI, this is always localhost column followed by a number. This number changes every time you open Power BI, so you don't know in advance what is this number. This number corresponds to the diagnostic port of analysis services for my sample report in Power BI. So 740. So if I go here and I edit, I just copied the same string. Once you do that, you still have to do two things. So you have to select the catalog. This is a strange number because in reality, analysis services could manage multiple databases. And even though Power BI has only one database in that instance, it has a strange name that you have to copy this way. You don't have a way to know this in advance. And you click OK. At this point, I suggest you to not refresh Power Pivot from here, but to simply go back to the Excel file, click on Vertipaq Analyzer ribbon, and then click on Refresh, just because it is faster rather than using Refresh from Power Pivot. Once I do that, I will see that the list of the tables that you see now is exactly the list of the tables I have in my model. And if I drill down, I can see for each table the list of the columns of this table. And for each table and each column, I know how many rows I have in the table, how many unique values I have in the column. And I can see also the size of the table in memory, summing the data, the dictionary, and many other information. Why this could be useful? The time that is required to scan your data depends on the size of the compressed data of the column that you query in memory. Every column has a different size depending on the compression. A table, imagine this column has only 3 unique values, and the data size for the entire column of a table that has 18,000 cities is 8 bytes. It's very compressed. So the time required to scan the continuum column is very small. But when a column contains, for example, the sales amount or the price, it will be more expensive. Let me check. If I go here, I can see that, for example, my column here, quantity and net price, which are the two columns used to do the calculation of the amount, require 43 and 45 kilobytes. We're talking about very small numbers. This is a model that will be always fast. I don't expect to see slow performance here. But in case you have 200 megabytes for just one column, you have to expect that you will need 100, 200, 300 milliseconds to scan that column only, okay? Depending on the hardware you have, of course. So at this point, I can say, okay, I checked that my model is small enough to not require 1, 2, 3 seconds, 4 seconds to run a query. So there is something wrong somewhere else, okay? But in other models, this could be important to evaluate. So Vertipaq Analyzer that you can download from this URL, and you can see also the article, provides you information that allows you to evaluate whether you might expect slow performance or not for your query. So we have seen that DAX Studio provides us some information, the logical query plan, the physical query plan, and the storage engine query. So let me quickly describe what is going on. The engine we have is an engine that has several parts. The DAX query that is received by analysis services generates a logical query plan that is transformed into a physical query plan. The physical query plan describes the steps that the engine has to perform in order to, 1, retrieve the data from the data source, which means retrieve the data from the storage engine. The storage engine is my model loaded in memory, because now I have Power BI file that loaded the model in memory. But in case you use direct query, your storage engine query will be the SQL query that you send with direct query in real time, okay? So these requests provide information to the formula engine. And the formula engine applies the calculation over the data that has been retrieved by the storage engine. Now, the storage engine might have different capabilities. For example, if you are using direct query, the storage engine you use is SQL Server, maybe, that can do a lot of things. Can join tables, do aggregations, and many other stuff. It can also perform operations over strings, for example. You can do an uppercase in SQL. Whereas if you are using the storage engine that is the one that you have in Power BI, in analysis services, when you import the data in memory, you're using a storage engine that is called Vertipack. Vertipack is a very quick and fast storage engine that manages data compressed in memory. It's very fast, but it's very, very simple in the operation it can perform. And for example, uppercase of a string is not an operation that the storage engine can do. The storage engine can do very, very simple operations. And let's say that this division of the task allows the engine to manage the retrieval of the data aggregated with the storage engine and applying other more complex calculations over aggregated data with the formula engine. This is the idea. So this is just to describe what is going on. DAX Studio, in reality, is intersecting SQL Server profiler information. So there are events that are the same events that, by the way, also in part the performance analyzer intercepts, that are events that provide information about what is going on. And these events provide information about the logical query plan, the physical query plan, and the execution of each single storage engine query. So what we do, we collect in DAX Studio these events, and we provide these events with a different user interface that is simpler to understand. So let me try to delve into this. Now that I provided you a quick introduction, the way I use this is the following. So my query is running in 3 seconds. Of these 3 seconds, I had 1 second in the formula engine after the formula engine obtained the data from the storage engine that consumed 2 seconds. So I would say, well, first of all, we have a problem in the storage engine. But I know from Vertipack Analyzer that my data is small, so it's not possible that I spend 3 seconds in the storage, 2 seconds in the storage engine. I need gigabytes of data, not 40 kilobytes, to spend so much time. So at this point, it's interesting to see that each single storage engine query has been executed in a very, very small amount of time. Look at the duration here. The duration is in milliseconds. This is the duration of each single storage engine query. So each storage engine query is running below the 10, 16 milliseconds that I said, anything that happens in less than 10 milliseconds, ignore it. You cannot optimize it. And everything is running in 1 millisecond, so it is fast. What is the problem? Wait a minute. I'm running 1,000 storage engine queries. That's a problem. In an ideal world, 1 DAX query, 1 storage engine query. Sometime 2, 3, 4, 10, but not 1,000 for a single visualization. So the cost of calling the formula engine costs the storage engine 1,000 times. At 1 millisecond for each call, 1 second. So we have a problem. We have to reduce the number of calls in this particular case. And how can I understand this? Well, if you see each storage engine query, this is the list of the storage engine queries sent from the formula engine to the storage engine, and this list tells me, oh, this is a list that provides up to 17,000 rows. What is this? The storage engine query is something similar to SQL. This is not SQL. This is called XMSQL, which is a language that represents, in a textual visualization, in a textual format, the internal request that the formula engine does to the storage engine. So the formula engine asks to the storage engine, give me a table that has product name and quantity from sales. And please pay attention, this is not product name and sum of quantity. This is product name and quantity. That's it. And this is obtained by joining sales and product, because the quantity is in sales and product name is in product, using the product key. When you define a relationship, you define a possible outer join for the storage engine. This is possible only with physical relationships. If you don't have a physical relationship in the model, there will be no join in the storage engine. with our condition. All these operations performed by the storage engine are usually very, very, very fast. Don't worry about this. And in fact, you see that this has been executed in 1 millisecond, generating a result that has an estimation of 138 kilobytes to the former engine. Now, the former engine is doing what? For each row of this result, is executing another query that says, distinct count of customer key from sales joint product where some condition. Wait a minute. What are we doing in the visualization? Why there is a distinct count for one product repeated for 1,000 products? If you see, every query here is very similar. This. It's always the same. What is changing is this condition. So let me go back to the DAX code. And if I go to DAX, and if I look at the DAX code, this is the code of the query. Now, this query is very simple, because this query, even though you don't know DAX at this level, because the syntax used by the queries is something that you will not use in your measures usually, but here I see that there is a reference to something called customers. And customers is something that in my Power BI model is exactly here. I can remove this now. These customers here is a measure. And if I look at the definition of this measure, this is my measure. This measure says calculate distinct count customer key from, calculate distinct count customer key, filtering sales where sales quantity is greater than 0. So basically, I want to count how many customers I have that have at least one sale. That's the idea. But there is something that is not working well, because actually this should be a single. Imagine in SQL, you can do something with a single group by. Why we are not obtaining a single storage engine query to do that? Now, at this point, imagine that you might have a more complex measure, a measure that calls other measures. When you are in DAX Studio, one feature you have is that you can include in the code that you see here the definition of the measure that you are using. For example, if I go in customers and I right-click, I can obtain, with define measure, I can copy in the code here the definition of the measure, or the definition, if I use define dependent measure, the definition of this measure plus all the measures that are used in an indirect way. Now, the definition of this measure is copied locally here, so if I apply a change to this measure will be executed instead of the measure that I have in my model. Why this could be useful? Because now I want to do some tests. I want to try to execute this query again, just to see if a change that I apply to the measure will be reflected in some performance improvement without modifying the model. So I'm not touching the model at this point. I want to be sure that only when I will have a very good measure, I will copy and paste my code. This is still slow. I didn't change anything. And at this point, I have to say, well, explaining why this measure is slow could be very hard from one point of view, because I should explain you for 2 hours how the engine works. But there is a simple way to explain what I did here. I didn't follow best practices. In Calculate, you should filter columns. In DAX, you should filter columns, not tables. What we're doing here, we are using a filter over a table within Calculate. I can obtain an semantically equivalent filter using a column by just replacing my filter over a table with this code. Now, this code is filtering a column, not a table. If you filter a table and you use sum, you would not have seen this huge performance problem in this simple model, but you would have seen some problem in a more complex model. But I wanted to create the simplest possible performance issue with the simplest possible model, just to show you that once I'm able to identify the problem and I click this run again, look at what happens. The execution time is reduced to 11 milliseconds. Why? Because now we have only 2 storage engine queries. First, I have a storage engine query that retrieves this. For each product, give me the distinct count of customer key, joining sales and product, doing a group by. Exactly what I would have expected in, also in SQL, for example. And the second one is just a distinct count without the product. Guess what? The grand total. Distinct count is not a cumulative measure, so you have to expect more than one storage engine queries in case the number cannot be cumulated. Okay? So at this point, I see, oh, finally, my code is working. I copy this code here in my definition of the measure customers in Power BI. I paste this code here, or sorry, I missed something. Customers, okay, let me fix the code here, key filters, and that's it. So now if I save this measure and I run my query again, so I can, for example, I can enable my performance analyzer again, and I can start recording and refresh visuals, you will see that now all my visualizations are executed in a much faster way. I still see that there is something that is slow, but when I open, now the only problem that exists, first of all, the slowest query is no longer my distinct count. There is something else, some sums. I don't know why. I should check what is going on. But basically, most of the time is other. Most of the time is other. I cannot do much. What is the problem of this report? Very simple. Too many visuals. You want to improve the performance of this report, try to reduce the number of visualizations that you have. So let me go back to the slides, just to recap what we have seen. The storage engine generates data that is called a data cache. The result of a storage engine request is called a data cache. And the data cache is the result of an XM SQL query that is consumed by the formula engine. The result of an XM SQL query is always materialized in memory uncompressed. So the reason why storage engine is faster in memory is because it works on compressed data, but once the data is transferred to the formula engine, the data is uncompressed. And this is another reason why you might have some performance issue. XM SQL is the language that describes the storage engine query, and the formula engine simply consumes this result, just like the formula engine can consume the result of a SQL query in case you use direct query. When you use direct query, instead of XM SQL, you're generating SQL code. But the architecture is the same, and the tools are the same. Remember, it is a good idea to clear the cache of analysis services before you run a query, which means that also when you are using this tool, Performance Analyzer, and you click on Start Recording and you refresh the visual, remember, refresh visual will execute all the queries again, but will not clear the cache in analysis services. If you want to clear the cache in analysis services, you have to either close Power BI and open Power BI again, or you can go in DAX Studio, you click this button, Clear Cache. Now I'm clearing the cache of analysis services, and after I did this, I can go back to Power BI, and I can click my refresh visuals that at this point will clear the cache of the rendering engine after I already cleared the cache of the analysis services engine. So this is another detail that could be important in performance issue that you have only when you open the model the first time. Internally clear cache sends this command to the engine. Conclusions. We have to identify the problem, isolating one query that we want to analyze. Once we isolate this query, we reproduce the problem using DAX Studio. We run the query with additional tools that can intercept the logical query plan, the physical query plan, and most important, the communication between the formula engine and the storage engine, which is the area where it is easier to identify the problems. And then, of course, you have to know DAX. And if you want to know more about query plans, how to optimize the code, we have a lot of documentation in white papers that you can download from SQL BI, and also there are 4 or 5 chapters of the Definitive Guide to DAX, which is a book that contains everything. There will be the second edition available in August, by the way. So if you are not in a hurry, in a few weeks, you will have a new edition that is more updated for Power BI. I think we are just on time. Thank you very, very much. If you have any questions. Any questions?